All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is Heating Curve Worksheet Part 2. If you've not completed Worksheet Part 1, you need to go back and take care of that now because of the fact that this one really won't make much sense to you if you don't understand the basic elements of a heating curve. So go ahead and take care of that and then follow us back here. Let's take a look at the kind of information that we've got here. We've got three substances to begin with. All three are water, but one's in the solid phase, one's in the liquid phase, and one's in the gas phase. I've given you specific heat data for those three. And then benzene, ethanol, and aluminums, also specific heat information for those three, and we're going to use those in this worksheet. I'm giving you boiling point information, melting point information, heat of fusion, and heat of vaporization for H2O, that's water, of course, benzene, ethanol, and acetone. All right, so we'll start there. You're also going to need molecular weight information, so I've included that right here. Water, of course, is 18.02 grams per mole. I've given it to you for benzene, ethanol, and acetone. So you're going to need that information to proceed with this worksheet. So let's take a look at the first one. So here's what it says. It says determine the following. How much heat in kilojoules is required to melt 34 grams of ice at 0 degrees Celsius? So we've got a 34-gram chunk of ice here, and we want to melt it. How do we do that? Well, what we're going to do is we're going to use the heat of fusion information. But before we do that, we're going to need to convert into moles. So we're going to start with a 34.0 grams of ice, 34.0 grams of ice at 0 degrees Celsius, and we're going to convert that to moles. So 18.02 grams per mole of water. That allows me to cancel this with this, and I'm going to be left with moles of water. Now, I've been told that the heat of fusion for water is 6.01 kilojoules per mole. So I'll multiply that across. I'll cancel moles of water with moles of water, and I'm going to be left with kilojoules. I'll multiply across and then divide, and I get this number, 11.3. To the correct number of significant digits, 11.3, and again, that's kilojoules of heat. So to melt the 34 grams of ice at 0 degrees Celsius, I'm going to need to apply 11.3 kilojoules of heat, and that'll do it for my first one. Let's go on to number 2. Number 2 says how much heat in kilojoules is required to melt 34 grams of benzene at 278.6 degrees Kelvin. Now, notice that we've switched to a different substance. This time it is benzene, so we're going to have to pay attention to that when we're looking at our data. So here we go. What we've got is 34 grams of benzene, 34.0 grams of C6H6 over 1 times the molecular weight of benzene is given at 78.12 grams per mole. That allows me to cancel here and here, and I'm left with moles of benzene. Now, I'm going to want to melt this, so I'm going to need the heat of fusion information. And from my table above, I see that 10.59 kilojoules is the amount of heat necessary to melt 1 mole of benzene. So I will cancel this with this, and I'm left with kilojoules. I'll multiply across, divide by the 78.12 on the bottom, and this time I get 4.61 kilojoules of heat. Notice kilojoules is left on top, so this will be kilojoules as well. So I'm done with the second one. Let's go on to number 3. Number 3 says how much heat is required to boil away 34 grams of ethanol at 351.5 K. Now, first of all, let's understand that we're beginning the process in the liquid phase because we want to go from liquid to vapor. We want to boil the ethanol. So we're going to start with the amount of that they've given me, which is 34 grams of ethanol. And then what I'm going to do is put that over 1 and convert that to moles. I've been told that 46.08 grams is the molecular weight for ethanol. So I'll put that on the bottom and 1 mole of ethanol on top. That allows me to cancel this with this, and I'm left with moles. Now what I'm going to do is I'm going to multiply that by the heat of vaporization. Remember, I want to boil this, not melt it. Heat of vaporization of ethanol. So that's 43.5 kilojoules per mole. I'll cancel this unit with this unit. I'm left with kilojoules, and I end up with 32.1 kilojoules of heat, and that'll do it for number 3. Let's move on to the next one. Number 4 says how much heat is required to boil away 34.0 grams of acetone at 329.4 K. Notice the 329.4 K just tells me at what temperature the boiling occurs, but it really doesn't figure into the problem. Important thing is I'm starting with 34 grams of acetone, so I'll start there. 34 grams of acetone over 1 times the molecular weight of acetone is 58.09 from the chart, 58.09 grams of acetone per mole. I need to get it into moles because of the fact that, first of all, I want to cancel across, but more importantly than that, the heat of vaporization for acetone is 30.8 kilojoules per mole, not per gram. So what I want to do is make sure that I've got it in moles. That allows me to cancel here and here, and I'm left with kilojoules of heat. So we've got 18.0 kilojoules of heat when I multiply across and divide, and that'll do it for number 4. Let's look at number 5. Number 5 says you have a sample of water with a mass of 28.0 grams at a temperature of minus 42 degrees Celsius. How many kilojoules of heat energy are necessary to do this? So we're going to make our way through the entire heating curve. We're going to start with ice. Again, we've got 28 grams, and we want to heat the ice to its melting temperature to start with. So we're going to use the formula Q equal mc delta T. Q is equal to mc delta T tells me how much heat must be applied to take the ice to liquid water. So I'm starting with 28 grams. So I'm going to use the formula mc delta T. 28.0 grams is the number of grams of ice that I've got times the specific heat of ice. So make sure that you're using the specific speed of ice and not of liquid water or steam. So it's 2.06 joules per gram per degree Celsius from the chart. And then I'm going to elevate the temperature of the ice from minus 42 to 0. So remember, the final temperature is 0. So I'm going to say 0 minus a minus 42. So the difference between these two is 42 degrees Celsius. Look how things are going to cancel. Grams and grams will cancel. Degrees Celsius on the bottom and degrees Celsius on the top are going to cancel, and I'm going to be left with joules. So I get 2,420 joules. I want it in kilojoules. I'll divide by 1,000. That gives me 2.42 kilojoules, and that'll do it for A. I'm going to try to keep everything here in kilojoules so that if I'm asked at the end to add everything up to determine how much energy is required for the entire process, I'll have it all in one unit. Let's look at B. It says how much energy is required to melt the ice. So I've got this 28 gram puddle now, because it's an ice cube to begin with, but I want to turn it into a puddle. How much energy would that take? So I'm going to start with the 28 gram of water over 1 times, I'm going to convert that to moles. I've been told that 18.02 grams is the mass of 1 mole of water. That allows me to cancel this with this. And now what I'm going to do is I'm going to use the heat of fusion for water, because remember, I'm converting solid ice into liquid water, right? So I'm going to use the heat of fusion for water, which is 6.01 kilojoules per mole. That's from the table. That cancels with that, and I'm left with kilojoules of heat. No need to convert it to anything. It's already in kilojoules. That's fine. I'm going to multiply across, divide by 18.02, and the number that I get to the correct number of significant digits is 9.34. Again, remember, it's already in kilojoules, so that's done for me already. Let's look at C. C says, heat the water. We now have this puddle of water, 28 gram sample of water, and we want to heat it from 0 to 100 degrees. And so what we're going to do is we're going to use the formula again. Q is equal to mc delta T. We want to heat water. We're not doing a phase change here, so we're not going to use the heat of fusion or heat of vaporization, but we want to use this formula right here for heat transfer. So we're going to say M, which is the amount of water in grams that I've got. It's 28 grams of water. I'm going to convert that to moles, 18.02 grams per mole. This and this are going to cancel away. and I'm going to be left with moles of water. I'm going to multiply that by the specific heat of water, which is 4.18 joules per gram per degree Celsius. And then what I'm going to do is multiply that by the temperature change. It's a 100-degree temperature change. I'm left with this value, 649.3. That's going to round to 650. Excuse me, that's 649.5. 650 joules is equal to, I want to convert that to kilojoules by dividing that by 1,000. And so I'm left with kilojoules, or 0.650 kilojoules. So that'll do it for C. Let's go to the next one. Now we want to boil the water. We've got 28 grams of water. It's liquid water, and we want to boil it. We're going to convert that to moles. It's 18.02 grams per mole. And then I'm going to apply the heat of vaporization, 40.7 kilojoules per mole. That is the heat of vaporization for water. And I get this number, 63.2 kilojoules. It's already in kilojoules, and so I don't have to do anything with that. And finally, I want to heat the steam from 100 to 104 degrees Celsius. I'll revert back to my formula. Q is equal to M times C times delta T. And so here we go. We've got the liquid water is 28 grams, but we're going to heat that steam. It's now steam, I'm sorry, not liquid water. 28 grams of steam, and we're going to multiply that by the specific heat of steam, 2.02 joules per gram per degree Celsius. And then the temperature difference, we want to go from 100 to 104. So we'll say final temperature minus initial temperature. When we do that, we're going to get 226.24 joules. We want it in kilojoules, so we'll move the decimal place over 3 places to the left, and that will give us the value in kilojoules of 0.02 or 0.226 kilojoules of heat. If I want to know the value, the total value for all of that, I'm just going to add them up. They're all in kilojoules, and they can add up very nicely and tell me what it would take, how much heat it would take to go from the very beginning where I had ice to the very end here where I have steam. That'll do it for this worksheet. I'll see you in the next one. Thanks. Bye-bye.